So the answer to this is option number D, and that is pretty easy to find. Let's discuss. Now, if you know this equation of motions, rectilinear motion, perhaps from class 9th, so you know that v square is equal to u square plus 2as. You know this? If it is starting from rest, that means the initial velocity is 0. So the final velocity v square, the velocity which it gains at this point, let me call that as v1. v1 square should be equal to 2. Acceleration, what will be the acceleration? Now, normal reaction and mg, normal reaction is perpendicular to the plane, so it has nothing to do with the motion along the plane. So mg is acting downward, mg cos theta is perpendicular, and mg sin theta is along the plane. So mg sin theta is the net force down the plane, so g sin theta would be the net acceleration. So it is coming down with acceleration of g sin theta, and the distance, suppose, is s by 2 if the total distance is s. So this will be the velocity. Now from here what happens, let's write the equation of motion from this point, midpoint, to the end. V square is equal to u square plus 2as. This is the equation of motion. Now final velocity they are saying should be 0. Okay, so this velocity, initial velocity for this motion, second half of the motion, is the final velocity of the first half of the motion. So this u is actually this u square is actually this. So what we get from here is 2g sin theta s by 2 is equal to, and the acceleration will be negative because the net force will be opposite to the motion. So we can write here as minus 2as. So this is 2a, and the distance is s by 2. Okay, so from here we get s by 2 cancels with s by 2, 2. So the acceleration you need is g sin theta. The required acceleration in the second half of the motion is g sin theta. Now, in the second half of the motion, you have friction force acting in upward direction because the motion is in downward direction, and mg sin theta is acting always in downward direction. So the net force upward is F minus mg sin theta. Net force upward, that should be from Newton's second law. Net force should be equal to mass into acceleration. Acceleration we got as g. What did we get? G cos theta. G sin theta. Okay, now so that's it. So the friction force is mu times normal reaction. Normal reaction is mg cos theta. That is friction force. This comes out as 2mg sin theta, and from here you can see that mu is going to come out as 2 tan theta. Okay. Another easy one. You have a block, you have a surface, and you are applying some force, suppose at an angle theta. Now the simple question is, what should be the minimum amount of force that you should apply in order for the block to start moving? Suppose the coefficient of friction is given as mu. So I'm giving you the answer. If you got your answer, then you're doing fine and you can skip the discussion. This should be the minimum amount of force that you should apply for the block to begin motion. It's pretty easy. The horizontal force is F cos theta. This should be just equal to friction force if you're looking at the minimum force. If you increase the force further, then the block will start moving with greater acceleration. But for the body to just begin motion, this horizontal force should overcome the friction force. That's it. Now the friction force is mu into normal reaction. Now the normal reaction is mg minus F sin theta. Can you figure this one out? How? mg sine theta is upward, normal reaction is upward, mg is downward. So normal reaction plus f sine theta should be equal to mg. So normal reaction should be equal to mg minus f sine theta. Okay, so this is friction force. Now from here we can see that this should be equal to f cos theta. Okay, now this f you bring here and then you divide the whole thing, you get f here as mu mg upon cos theta plus mu sin theta. Pretty easy, okay? But we're just starting, we are warming up. Okay, now similar to the previous situation, suppose the force this time is not pulling the body, but it is pushing the body like this. Previously it was pulling the body, this time it is pushing the body. Now if it is pushing the body, then this time you tell me what should be the minimum amount of force that one should apply in this orientation so that the block just starts to move and the coefficient of friction is mu.